Now our topic is difference between SQL and NoSQL databases. We have already uploaded a course DBMS Module 1 in which we have already discussed in detail the common types of databases. Here we will concentrate on only two types of databases, SQL and NoSQL databases. Now the first difference on which we will be discussing is the data model. SQL databases primarily use relational data model. What is the relational data model? Relational data model is a model which makes use of tables to store data. In the table, there are rows and columns in which the data is stored. Now, in the case of NoSQL databases, they use various data models such as documents, key value, common family, graph, etc. Now the next point is schema. SQL databases have a predefined schema, which means that the structure of the database of the data in the database is fixed and well defined in advance. This makes it easy to query the data and ensure that the data is consistent. On the other hand, in the case of NoSQL databases, these databases are known for their flexibility and schema-less or schema-flexible approach. NoSQL databases are better suited for scenarios where data structures are less predictable or frequently evolving. Frequently evolving means the nature of the data changes. Now, another point is query language, structured query language. SQL databases use the structured query language, that is SQL as their query language. SQL is a powerful standardized language for querying and manipulating data in relational databases. On the other hand, in the case of NoSQL databases, they use different query languages depending on the data model. We will discuss about various types of data models in the coming courses. For example, key value databases usually do not use complex query languages for data retrieval. These databases retrieve and store data quickly using keys. Another example is each document database may have its own query language. MongoDB, being a specific document database, uses its own query language MQL. Now the fourth point is scalability. SQL databases are typically designed for vertical scaling, that is scaling up, which means that the performance of the database can be improved by increasing server resources like CPU, memory, and storage or other resources. You have seen the trees which grow in this way, that is upward. So this is known as vertical scaling. Suppose there is a house, there is a vacant plot, and you have built a room on it which can accommodate say 2 persons. With the passage of time, the size of the family increases and you have two options before you. Either you take or build a separate house, or you can construct another room on it. On the same plot, you can construct another room. It is in the same way that in the case of SQL, there is vertical scaling. That is, we do not add more servers to meet up the expectations. That is, if the organization feels that the volume of data is increasing, it needs to make use of more servers or upgrade the present server. In this case of SQL, vertical scaling is used. That is, this server is upgraded, its memory, its storage capacity, or CPU is increased, and though scaling out, that is adding more resources, can be possible in the case of SQL, but adding more servers is complex and expensive for SQL databases. So in the case of SQL, it is preferred that scaling, a vertical scaling, that is scaling up technique is used. That is, we increase CPU, RAM, storage and other resources so that we can handle the increasing data volume. Whereas in the case of NoSQL databases, they are designed for horizontal scalability. Horizontal means in this way, that is increasing the number of servers so that the increase in that data may be properly handled, which means that the performance of the database can be improved by adding more nodes or servers to the database. NoSQL databases can continue to function even if one or more nodes fail. That is, suppose if there are 4 servers working, even if one server fails, other servers will continue to function, and overall the functioning of the organization will not be affected. You can you can scale your NoSQL databases up or down as needed. That is, if the organization feels that the volume of data has which it has to deal with has decreased. Suppose the organization's business is not growing at a very fast speed, and the organization thinks that it need not to have the facility of as much servers as it is utilizing as on day. So it may decide to reduce the number of servers it is using. Adding more servers can accommodate increased traffic or data growth, and you can remove nodes when demand decreases. That is, when the demand of, of, of the servers in respect of the service you want to provide decreases, that is, the your need for data storage decreases, then automatically you can decrease the number of services. This is possible in case of NoSQL databases. Next point is use cases. SQL databases are best suited for structured data. We give the examples of structured data. These are customer records, product inventory, and financial transactions. Whereas in the case of NoSQL databases, they are best suited for semi-structured or unstructured data. And the examples of the same are social media posts, reviews, hashtags, audio video files. Another point is development speed. SQL that the development speed of SQL is slower due to schema constraints. What is the meaning of development speed? Development speed means the time and effort required to maintain and build a database system. That is, it takes a lot of time and effort to build a SQL database system in the case of SQL. Whereas in the case of NoSQL, development speed is faster due to schema flexibility and dynamic data. Next point is ACID compliance. We have already discussed in detail about the ACID properties in DBMS, which is atomicity, consistency, isolation. Now, SQL databases are traditionally designed to follow ACID properties strictly. NoSQL databases vary in their degree of adherence to ACID properties. Some NoSQL databases, especially new SQL databases, provide strong ACID guarantees. That is, they strictly follow the ACID properties in DBMS. D stands for durability, while others prioritize performance and scalability over strict ACID compliance. Now, another point is atomicity. SQL databases guarantee that transactions are atomic. That is, the transactions either are fully completed or fully rolled back in case of failure. The failure may be power failure, internet failure, or any other. There are no partial transactions. In the case of NoSQL databases, atomicity depends on the specific NoSQL database. The atomicity of the transactions may be more relaxed. Next point is consistency. SQL databases ensure data consistency, enforcing rules and constraints. We will also discuss in detail how the relational model ensures data integrity through constraints and rules. On the other hand, NoSQL databases, the level of consistency enforcement varies among NoSQL databases. Some NoSQL databases offer strong consistency, while some other NoSQL databases provide eventual consistency, which allows for temporary consistencies that are resolved over time. Next point is isolation. SQL databases provide isolation between concurrent transactions. This means that concurrent transactions do not interfere with each other, and each transaction appears to run in isolation from others. Isolation levels in NoSQL databases can differ. Some databases offer strong isolation, while some other NoSQL databases offer weaker forms of isolation. Next point is durability. SQL databases guarantee the durability of committed transactions. Committed transactions are those transactions which have been saved in the database. Once a transaction is committed, its changes are permanently stored and will survive system failure. Durability guarantees are typically maintained in NoSQL databases. Once data is committed, it is durably stored. However, in certain situations, some NoSQL databases allow users to reduce the level of durability in exchange for improved system performance. Next point is data structure. SQL databases store data in tables which is made up of rows and columns. Each table in a row represents a single record, and each column contains a single piece of data about that record. You have already learned that in the case of a relational model, there are rows, these are the columns, and we may here take the example of employees. In that case, there may be column heading employee name, employee ID, then employee contact number, and much more. These are, this is row and this is the column. This is what is written in this row is known as the record, and what is written in the columns, it is known as a single piece of data about that record. On the other hand, NoSQL databases store data in different ways depending on the data model they use. For example, key value databases store data as pairs of keys and associated values. Document databases store data as documents, and graph databases store data in the form of graph-like structure. Now we will see the examples of SQL databases. The examples of SQL databases are Oracle database, MySQL, Microsoft SQL Server. In the case of NoSQL databases, the examples are MongoDB, Cassandra, Redis, Amazon, DynamoDB. Now we will conclude the difference between SQL and NoSQL databases. The choice between SQL and NoSQL databases depends on the specific requirements of the application, that is data structure, scalability needs, query complexity, or performance goals. Many organizations use both SQL and NoSQL databases together. Why? To handle the different types of data storage and retrieval requirements. For example, an organization might use a SQL databases to store customer data, and the same organization may also use the other database, that is NoSQL database, to store social media data. We may take the example of Amazon. It may use both types of DBMS, SQL to store the customer information or product catalogs, and NoSQL database to store social media data, that is the audio video files, reviews by the customers. If the organizations use both type of databases, then it allows the organizations to get the best of the two worlds. To get the best of the two worlds means to get the benefits of both types of databases. And what are those benefits? The flexibility and scalability of NoSQL databases, and the performance and ACID guarantees of SQL databases. That is, the organization can take the benefits of strengths of both these types of databases if they use both of these databases. Thanks for watching. If you like our course, please spare some time to give a star rating to our course.